this process where memories that have been consolidated, the content of the memory can arise, and depending on the situation in which it arises, it can be updated.
Mm-hmm.
And in that update, there could be repetition errors where
Yeah.
it gets updated maybe incorrectly, it evolves over time, or it could be upgraded not so much incorrectly, but evolving, changing over time. And that in the content of this memory, it's not just faces or names or physical sensations, but there's also an aspect of what that memory means. Like meaningness is also content for memory. Can you talk a little bit about that?
Sure, absolutely. So there's a couple of I guess what I've explained so far is more of the very molecular and cellular level, exactly what's happening inside the neurons. But the brain is not independent neurons working together necessarily. It's systems. It's organized itself in systems. And there's a couple of brain regions which are particularly important in laying down memories. One of them, which is the hippocampus, which is probably the most famous region that's involved in memories. And while we've known that the hippocampus is very, very important for this from previous studies, historically, it has been demonstrated that if you remove the hippocampus from someone's brain, that person is not going to be able to form new memories. But more recently, I think just like 2 years ago, if I am correct, there's this team at Cambridge University that has done a very interesting experiment looking at the hippocampus. So they put people into the scanner, and then they were showing them images from a film called Forrest Gump. You've probably heard of it.
Mm-hmm. Oh, yeah.
And then they were trying to look at the activity of the hippocampus in real time as the people were being asked to memorize the scenes in the film that they were watching. So what they were seeing is that when people were actively trying to memorize, then the activity in the hippocampus was going up. And when they would stop memorizing, so at the end of the film scene that was being presented to them, the activity in the hippocampus would go back down again to the baseline level. So the hippocampus is one of the brain regions that's super, super important here. But there are a couple of others which I would like to mention as well. So one of them is the prefrontal cortex, which is majorly responsible for us being able to choose what we are trying to memorize or not. So if we're interested in memorizing something in particular, then we're going to make much more of an effort. And this is how this brain region is going to be involved in the process, by facilitating this more higher order process like decision making about something. And another region which is super important is amygdala. And here is actually where I'm finally getting to answer the question that you're asking about the emotional salience of memories. Because the amygdala is a region in the brain that is particularly important for anything that's emotional content. And the general association of the amygdala is to do with fear, for example, with fear memories. So let's just say in the context of diseases such as post-traumatic disorder, by having a very, very emotionally challenging experience or something that induces a great degree of fear, that's going to lead to the memory being encoded into the hippocampus much strongly. And it's actually really fascinating because the amygdala and the hippocampus are actually so close together, biologically speaking, that it just poses the question at the end of the day of how important memory is for us as a species in terms of this ability to learn about learn about fearful stimuli in the environment in order to avoid them later on. So this is in great lines how it's happening. However, not to say here, because I understand that what I'm saying might also lead to the conclusion that there is just these three distinct brain regions that are involved in encoding memories and in stabilizing them and so on. But that's not actually the case. It's not like it's these particular regions and only them. The brain is a dynamic system. It's a particularly dynamic system where there's a lot of information flowing inside of it. And of course, more other regions are involved, such as the thalamus for sensory encoding and the cerebellum for procedural memories that involve moving your body, for example. And there's electrical signals do travel around the brain in many other regions, not only the ones that I mentioned. But this would be of particular notice.